Assalamualaikum and very good day for everyone. Now we continue our embedded system chapter number 6, which is analog to digital conversion. Before that, I hope you all complete all what I have shared for previous chapter, which is uh, LCD and keypad. Alright, so the learning outcome is to understand the importance of the analog to digital conversion, identify pins and modules related to analog to digital conversion, able to program the analog to digital conversion process and its application. Actually, analog and digital you must know a lot because you have learned during your semester 1 you have digital system electronics, and then I think in your third semester you have analog system subject. So hopefully you all know well what difference between analog and digital. Here is the difference between analog and digital. So we start with TV. We have analog TV and digital TV. We have the picture here. Analog digital got some different here. For the LCD projector, this one is analog because you need to display by manual and so on. This one we can see digital. Here we have analog and digital camera, and then this one for sure you have analog clock and digital clock. And this one, which one is analog? Okay, this one we consider as analog because you need to pump by using manual, and then this one automatic. Alright, here's the difference. Here's the analog signal. You can have the sine wave, and then when you convert into digital it will become this step. Actually, this one you have learned in ADC chapter on your electronic device. Sorry, digital electronic and system. This one is conversion. For example, the voltage will be different, and then because why you need to convert from analog to digital? Because computer microcontroller can only read in digital. For example, if you learn C++ previously, you may only why you need to compile? Because computer cannot read the wording. For example, scan C in, C out, they cannot know. They can only read 0 and 1 only. So when you compile, actually you convert into computer language, which is in digital. So here is the example. You want to convert from 5, they might be convert will become 1010 and so on. Maybe, I don't know. Okay, this is the need of conversion. Again, because microcontroller can only read digital, the CPU here. For you have sensor will provide you analog signal. They come to microcontroller, and we have ADC, analog to digital conversion, and then they convert into digital signal. When you have digital signal, then your microcontroller computer CPU inside your microcontroller will read and do operation whatever you want before display at the output. Now we have resolution. Resolution depends on your microcontroller itself. For example, for Arduino Uno, we have 10 bits of ADC. That means when you have 5 volt, they will read as 1111 1111 for 10 bits of 1. Then this one is 5 volt. This one is 5 volt. And then this one represent 0 volt. Okay. Next, how you want to calculate? For example, this example, you have 5 volt input, and then it will convert into digital by using 8-bit ADC. So, what is the voltage for every step? Step mean when you have 0000 to 0001, they will present one step. 0001 to 0010 is another step. So how you want to calculate? 5 divided by 2 power of 8, then you will have 19.5 millivolt. Now, just simple exercise. For 10 bit of ADC, we have 5 volts. So what is the step size? Same equation like above. 5 volt divided by 2 power of 10. And then you will have the answer. Very simple. What the answer? Here is the answer. You have number of bits. You have 10 to 4, 10 bits. Then if 5 volt, you will have 4.88 millivolt for every step. This is the table. For example, maybe the reference voltage is 5 volt. Then you will directly calculate this one. What happens if the reference voltage is less than that? For example, for this case, 4 volt. You have 4 volt. Then the range will be 0 until 4. So the step size is smaller. You can see here. For example, you have 3 volt of V reference. The maximum voltage 3 volt, maximum voltage input, and then conversion we have another much smaller step size. Okay, Arduino Uno analog header location. Okay, where is the analog reader in the Arduino? Or you just ignore the circle tadi I terbuat. Okay, now the analog location we have here A0 until A5. You know it's already how many analog input we have? 6. A0 until A5. This one you will have 5 volt maximum, 0 volt minimum. But this still depend to the input reference. For example, here we have Vin. Vin here, if you supply, then you will have 5 volt. If you put 10 volt, that means the analog input will refer to the 10 volt. Oh, this one, I don't remember which one. Oh, no, sorry, not Vin. IO reference here. IO reference. Mean reference voltage here. If you write 10 volt, for example, sensor, some sensor will have 5 volt. But there is some sensor that use 10 volt or 12 volt as the reference. With 10 volt or 12 volt, if this one limit until 5 volt, then that sensor cannot be applied in the Arduino. No, you can apply it. You must input the reference voltage here to 12 volt, and then you will see the configuration to analog is still similar. Only the reference voltage is 12 volt. Okay. Now this is, you may read by yourself. You have 10 bit, 48 mega is our Arduino Uno. 10 bit of data, ADC conversion, and then the samples is 50k sample per second. That means very fast. So the conversion is 13 microsecond conversion time. Means you have analog input, 13 microsecond you convert already. Nowadays it need to be fast. And then we have 6 multiplex single-ended input channel. Previously A0 until A5. And then we have free running single conversion mode. We may apply interrupt and ADC conversion complete. How is work in Arduino? Okay, you have this one I say though. The analog input voltage you must have Vs analog input, and then connect to the analog A0 until A5 sorry. And then we have input reference voltage. This one Vref. To keep the illustration as simple, the reference voltage is not shown and may be assumed to be equal to 15 volt. If you supply 5 volt, then it will assume 5 volt. Depends. The maximum is 15 volt. And then here you may ignore, you may read by yourself the supply comparator, analog voltage, so on. Now this is the configuration, how it's set up. Here, for example, you have supply voltage 7.2 volt. And then you have the analog input here up to 7.2. So this one is V reference lah. This one. Then they convert into digital. But this one is a 4-bit ADC lah. Very old timer punya Arduino microcontroller. Nowadays we have minimum 10 bit. 8 bit also very old school already, we can say. And somehow we have much higher. 64 bit we have, 32 bit, but it depends. 10 bit is enough for me. Arduino